Hi everyone, welcome to Rao's chemistry classes. In this video, I am going to explain how to find out aromatic compound. What aromatic compound explain? Aromatic compound explains stability. But what about anti? Anti is nothing but opposite, unstable. So ultimately, you need to understand one important point. If you understand aromatic concept and anti-aromatic concept, no need to focus on non-aromatic concept. Why? Because that is completely bonus. Yeah, so that's the reason you have to focus on how to identify aromatic compound and how to identify anti-aromatic compound. So most of the students going to get confusion. So how to identify aromatic and anti-aromatic, non-aromatic concept. So after watching this video, your confusion completely wash out. I am giving that much assurance. Is it clear? Yeah. So before getting to concept, I would like to give one important motivation point. That is, in English one saying is there. That is, there is a war behind every comfort we desire in life. జీవితంలో మనం కోరుకునే ప్రతి సౌకర్యం వెనకాల ఒక మినీ యుద్ధమే ఉంటుంది. సో దీస్ ఆర్ ద కండిషన్స్. ఫస్ట్ ఐ యామ్ గోయింగ్ విత్ ఎగ్జాంపుల్. మై ఎగ్జాంపుల్ ఈజ్, దిస్ ఈజ్ మై ఎగ్జాంపుల్. ఫస్ట్ ఐ యామ్ గోయింగ్ విత్ దిస్ వన్. దిస్ ఈజ్ benzene. Is benzene is aromatic compound or not? So let me check each and every point. So is benzene is cyclic compound or not? Yes, cyclic compound. Cyclic is required. Yes, that is cyclic. Next, double bond is there? Yes, double bonds are there. Okay. Next, conjugation. Conjugation means double, single, double, single, double, single. Yes, alternate to double bonds. If compound contain alternate to double bonds, that is resonance condition. That is conjugation. If compound contains double bond, single bond, positive charge, that is also conjugation. If compound contains double bond, single bond, negative charge, that is also resonance. If compound contains double bond, single bond, lone pair, that is also resonance. So don't get confused. Is it clear? Yeah. So here, what about this one? Double, single, double, single, double, single. So resonance possible. So it is a cyclic planar molecule. It is a cyclic planar molecule. So planar is nothing but all are sp2 carbons. Otherwise you can follow like that. Each and every carbon hybridization should be sp2. Otherwise not possible. So here, what is the hybridization? You tell me. This is carbon, carbon having a double bond and single bond, then you have to give priority to double bond. Then what is the hybridization? sp2, same logic 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 sp2. So here benzene contain total 6 carbons, 6 carbons undergoes sp2 hybridization only. If compound contains all carbons undergoes sp2, that is called cyclic planar molecule. So actually this is also one of the condition, cyclic planar. How it act as cyclic planar? Why? Because all are same plane, having same plane. Yeah. Okay, anyhow, next, what is the Hückel's rule? 4n plus 2 into pi electrons. So here benzene contain how many double bonds? 3 double bonds. So everybody knows one point, that is 1 double bond equal to 2 pi electrons. But here 3 double bonds. 3 double bonds means 3 into 2 pi electrons. Then it becomes a total 6 pi electrons. So 6 pi electrons means aromatic. So finally, benzene is aromatic compound or not? Yes, benzene is a aromatic compound. Benzene is a aromatic compound. Next, second example. What about this one? Cyclopropane. Is cyclopropane is aromatic or anti-aromatic or non-aromatic? Cyclopropane. Yeah, let me check one by one. What is the first condition? What is the first condition? Cyclic compound. Cyclic compound. Yes, it is a cyclic compound. First condition satisfied. Next, second condition, double bond. But there is no double bond. That's the reason it is not a aromatic, it is not a anti-aromatic. That's the reason it is a non-aromatic. Already I told you, एरोमेटिक को नहीं होते ना, एंटी एरोमेटिक को नहीं होते, हमारे ऑटोमेटिकली वो क्या होते? नॉन एरोमेटिक होते. नेक्स्ट थर्ड वन, सपोज मैं आपको ऐसा दिया साइक्लोप्रोपेन. की पॉइंट्स, जस्ट गो थ्रू की पॉइंट्स. फर्स्ट वन cyclic. Yes, cyclic compound. Double bond is required. Yes, double bond is there. Next, conjugation. Double, single, single. So there is no conjugation. That's the reason. Third rule, not satisfied. That's the reason it is a non-aromatic compound. It is a non-aromatic compound. देखो स्टूडेंट्स, अगर फर्स्ट कंडीशन सेटिस्फाई नहीं हुआ तो सेकंड कंडीशन देखने का जरूरत नहीं. फर्स्ट टू सेकंड टू सेटिस्फाई हो गया तो थर्ड कंडीशन देखना. अगर सेकंड कंडीशन सेटिस्फाई नहीं हुआ तो थर्ड कंडीशन नहीं देखना. अगर थर्ड कंडीशन सेटिस्फाई नहीं हुआ तो फोर्थ कंडीशन नहीं देखना. आर यू गेटिंग माय पॉइंट? यस. इसमें एक कंडीशन फेल हो गया तो भी वो नॉन एरोमेटिक के होते हैं ऑटोमेटिकली. या सो एंड वन मोर इंपॉर्टेंट पॉइंट, aromatic anti-aromatic first 3 points same, only last Hückel's formula is different. That's it. You just notice that point. Just have a look. Cyclic is required, cyclic is required, double bond is required, double bond is required, conjugation is required, conjugation is required. First 3 points 100% is same, but what is the fourth one is different. Here formula is 4n plus 2 into pi electrons. Here formula is 4n pi electrons. Yeah. Next, one more example for better understanding purpose. This is very important. What about this one? What about this one? This is Cyclopropenyl cation. Yeah. So already I told you in our chemistry what are the rules of conjugation: double, single, double, alternate to double bonds. Next, double, single, positive, that is also resonance condition. Double, single, negative, that is also resonance condition. Double, single, lone pair, that is also resonance condition. Just have a look. This is double bond, this is single bond, this is positive charge. Yes, resonance possible, so resonating structure possible. That indication conjugation is there. Acha, is it cyclic planar or not? All carbon should be sp2. Let me check it. Yeah, so this is carbon, this is carbon, carbon having double bond, carbon having double bond. If carbon having double bond, that is sp2. Carbocation, all carbocations undergoes sp2. Okay, sp2, sp2, sp2. That indication is it a planar molecule or not? 100% it is a planar molecule. Conjugation means planar only, don't get confused. Yeah, next. So here one double bond is there. One double bond equal to 2 pi electrons. One double bond equal to 2 pi electrons. 2 pi electrons means, yes, 2 pi electrons. 2 comes aromatic. That's the reason this is a aromatic compound. It is a aromatic compound. Is it clear? Yeah, just have a look, take screenshot. If you know aromatic and anti-aromatic, then non-aromatic bonus. Yeah, so what is the first condition for both? First condition for both. What is the first condition for both aromatic and anti-aromatic compounds? Cyclic compound is required. Cyclic compound is required. Next, what is required? Double bond is required. At least one double bond is required. Next, what is required? Conjugation is required. Conjugation is required. These three required, isn't it? Yes. What is conjugation? Conjugation is nothing but resonance. Conjugation is nothing but resonance. What are the conditions for resonance? What are the conditions for resonance? Already I told you. What are the conditions? These are the conditions. First one, alternative double bonds. Alternative double bonds. Shortcut DBS. Double, single, double, like that. Next, second condition, double, single, positive charge. Next, third condition, double, single, negative charge also. Yeah. Next, fourth condition, double, single, lone pair. Next, fifth condition, this is also possible, double, single, free radical. Yeah, these are the main conditions. Okay, so Hückel rule is different. For aromatic compounds, 4n plus 2 into pi electrons. For anti-aromatic compounds, 4n pi electrons. These two formulas very much important, keep in your mind. Yeah, next I am going with some examples. Already we have discussed some examples. Next I am going with this example. This is previous year question. This is previous year question. What is the name of this compound? Cyclopentadienyl. Positive is nothing but cation. Now you tell me, is it aromatic or anti-aromatic or non-aromatic? Just have a look. Is it cyclic compound or not? Yes, cyclic compound. double bond is there, yes, double bond is there, conjugation is there, yes, conjugation is there, डबल सिंगल पॉजिटिव, अगर ऐसा देखा तो भी चलता, डबल सिंगल पॉजिटिव। नहीं तो ये काम करो, अगर ये समझ में नहीं आए तो ये लॉजिक अप्लाई करो। व्हाट इज द लॉजिक? ऑल कार्बन शुड बी sp2। या C plus is nothing but sp2, already I told you. Carbon having double bond sp2, 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 all carbons sp2 means is it cyclic planar or not? Yes, it is a cyclic planar. It is a cyclic planar. Conjugation is nothing but cyclic planar. Next, one more important point here, formula. Which formula is suitable here? First, before that, how many double bonds here? 2 double bonds. 2 into 2 pi electrons. 2 into 2 pi electrons means 4 pi electrons. 2 into 2 pi electrons बोले तो 4 pi electrons. 4 pi electrons बोले तो which formula is suitable? This formula. 4n pi suitable. Why? Because if you substitute n value 1 here, then it becomes 4 pi. Yeah, 4 pi, 4 pi. Is it clear? So is it aromatic compound or anti-aromatic compound or non-aromatic compound? It is a anti-aromatic compound. It is a anti-aromatic compound. Is it clear? Yeah. Next, one more question. So what about this one? Yeah. What is the name of this compound? Cyclopentadienyl anion. Cyclopentadienyl anion. Same logic. Cyclic compound, double bond is there, conjugation also is there. Double single lone pair, double single lone pair. Yeah. Is it cyclic planar or not? Yes, cyclic planar. Why? Because here you are going to get one small doubt. आपका डाउट क्या है बोले तो सर कार्बोकैटायन्स अंडरगोस sp2 hybridization and carboanions undergoes sp3 hybridization. You have given this statement, sir, but then here you said all carbon should be sp2. Then what about this one, sir? Is it sp3? No, it is not sp3. This is the logic. I will tell you the logic. Actually C minus बोले तो कार्बोएनियन बोले तो sp3 आना, बट इधर क्या होते देखो, ये रेजोनेंस में ये लोन पेयर खाली नहीं, ये रेजोनेंस में पार्टिसिपेट होते. सपोज इफ आई शिफ्ट दिस बॉन्ड हियर, दिस लोन पेयर इज गोइंग टू पार्टिसिपेट. दैट्स द रीजन हियर हाइब्रिडाइजेशन इज sp2 ओनली. दैट्स द रीजन इट इज आल्सो cyclic planar. Yeah, it is not free lone pair. This lone pair involved in resonance. Because of that reason, this one doesn't get sp3 hybridization. This one get sp2 hybridization. Okay, anyhow, conjugation possible. Last and final, and one more important point. Generally maximum students क्या करते हैं सर, two double bonds ना, two double bonds बोले तो like here also two double bonds. That's the reason 4 pi electrons. They will simply say anti-aromatic. It is a simply wrong answer. Why? Because here lone pair involved in resonance. That's the reason you need to consider these two electrons also. Finally, here how many pi electrons? 6 pi electrons. That's the reason. Is it aromatic or not? Yes, it is aromatic compounds. So each and every student focus on these two examples. This is a cyclopentadienyl cation. This is cyclopentadienyl anion. So here lone pair also consider करना पड़ेगा, इसलिए 6 pi electron, इसलिए aromatic आया. Is it clear? Okay, good. Okay, next, these are very important. This is cycloheptatrienyl anion. So is it aromatic or anti-aromatic or non-aromatic? It is anti-aromatic. Why? Because here you need to consider 2 electrons. Then total 8 pi electrons. It satisfies this rule, this Hückel's rule. Next, this is also important. Tropylium cation. So tropylium cation also condition satisfied and it follows 4n plus 2 pi electron. That's indication that it is aromatic. 6 pi electrons means aromatic. Next, what about this one? Cyclohexadienyl cation. Actually here resonance not possible. Why? Because double single. So resonance not possible. That's the reason it is not aromatic. It is not anti-aromatic. That's the reason it is a non-aromatic compound. Yeah, just have a look. Already we have discussed some examples, some more examples for better understanding purpose. Just look at the board. Yeah. What about this one? Is it aromatic compound or not? What about this one? Yeah. It is a heterocyclic compound, isn't it? Yes, it is a heterocyclic compound, but you need to observe very carefully. So, double, single, that indication lone pair should involved in resonance. Why? Because this is a heteroatom, left side single bond, right side single bond. This is the fixed logic. If heteroatom, left side single bond, right side single bond, that indication 100% lone pair should involved in resonance. But when comes to pyridine, one side double bond and one side single bond is there. That's the reason in pyridine lone pair does not involved in resonance. Are you getting my point? Yeah. So that's the reason here you need to consider lone pair also. Yeah. So first condition cyclic compound, yes it is a cyclic compound. Second condition double bond is required, yes double bond is there. Third condition conjugation is required. Already I told you conjugation is nothing but resonance. Yeah, here resonance possible or not? Yes, resonance possible. And one more important point, this lone pair involved in resonance. So total 2 double bonds means 4 electrons, and you have to add these 2 electrons also. Then total how many pi electrons? 6 pi electrons. 6 pi electrons means aromatic compound. 6 pi electrons means aromatic compound. Yeah. What about this one? Cyclic compound. Yes, double bond is there. Yes, but a conjugation only one side possible, but a completely conjugation not possible. What is our condition? Fully conjugated is required, but here 50% conjugation is possible. Anyhow, third condition is conjugation. Conjugation condition failed. That's the reason this is not aromatic compound. It is not anti-aromatic compound. It is non-aromatic compound. Shortcut Na. So what about this one? This is very simple. Very simple. Here conjugation not possible. All carbons are not sp2. So this is also non-aromatic. This is very simple. Why? Because it does not contain double bond. That's the reason second condition failed here. Next, as it is not a cyclic compound. First condition also failed. It is not a cyclic compound. First condition failed. That's the reason this is also non-aromatic. This is also non-aromatic. Yeah. Sometimes in examination they are going to ask like this, stability order. Sometimes in examination they are going to ask stability order. Yeah. So 1, 2, 3. Out of 3, which is more stable? Take 10 seconds, no problem. Try to give the correct answer. Yeah. So out of 3, which is more stable? Yeah, before this is the stability order. Out of 3, which is more stable? Aromatic is more stable. Next to non-aromatic, next to anti-aromatic. So already I told you, aromatic is nothing but aromaticity explains stability. Aromatic inversely proportional to anti-aromatic. That's the reason aromatic explains stability. Anti-aromatic explains instability. So this is the order: aromatic greater than, non-aromatic greater than, anti-aromatic. Okay, anyhow, what about this one? 2 double bonds here. So that indication this is 4 pi electrons, this is anti-aromatic. What about this one? There is no double bond, that indication this is not aromatic, this is not anti-aromatic. That's the reason this is non-aromatic. What about this one? Yeah, so already we have completed this example. This one and this one both are same. What is the answer? Non-aromatic. But now you are going to get one small doubt. Your doubt is, sir, this is non-aromatic, this is also non-aromatic, but out of 2, why this is more stable? Let me explain very clear. So here double bond, single bond, positive. That indication here of conjugation is there. That indication here one resonating structure possible. That's the reason, because of resonance this is more stable. Because of anti-aromaticity this is unstable. Anyhow, out of 3, which is more stable? This is more stable. Is it clear? Yeah. Is cyclooctatetraene is aromatic compound or anti-aromatic compound or non-aromatic compound? Yeah. So most of the students definitely they are going to give this answer. Your answer is anti-aromatic, but my answer is non-aromatic. Don't get confused. Let me explain very clearly, listen very properly. Yeah. So when you look at this structure, definitely you will get this answer. But practically, this is unstable structure because of ring strain. Because of ring strain, it is unstable. It is converted into tub form. It should convert into tub form. It should convert into tub form like this. Yeah. But actually, what is the condition of aromaticity? One of the condition is the compound should be cyclic planar. But actually, this is a cyclic planar. When it comes to this one, this is not a cyclic planar. This is above the plane, this is below the plane. So it is a non-planar molecule. It is a non-planar molecule. That's the reason non-aromatic is the correct answer. This is wrong answer. This is a different example, special example. This is exception. Yeah. So cyclooctatetraene, because of ring strain, it is unstable. It should convert into tub form. So tub form is a non-planar molecule. Because of that reason, this one shows non-aromaticity. It is not a aromatic compound. It is a non-aromatic compound. It is not a anti-aromatic compound. Generally, you will get anti-aromatic. Why? Because here 4 double bonds are there. 4 into 2 pi electrons, 8 pi electrons. 8 pi electrons means anti-aromatic. But that is practically wrong. Just notice this point. Yeah. Next, which is more stable compound? Based on stability order. What is our stability order? This is the stability order. This is the stability order. Aromatic greater than, non-aromatic greater than, anti-aromatic. First you have to identify which one is aromatic and which one is non-aromatic and which one is anti-aromatic. Everybody knows benzene is aromatic compound. Yeah. So this is aromatic. This is a cyclohexane. There is no double bond. That indication here conditions are failed. Because of that reason, this is non-aromatic. What about this one here? 2 double bonds are there. 2 double bonds means 4 pi electrons. 4 pi electrons means it satisfies 4n pi Hückel rule. That's the reason this is anti-aromatic. Now you tell me. Yeah. Aromatic greater than, non-aromatic greater than, anti-aromatic. So already I told you what aromaticity explains. Aromaticity explains stability. So here which is more stable compound? This is more stable compound. Suppose in examination, suppose if they ask like this, which one out of all, which one is a unstable compound? You should give this answer. Is it clear? Next, sometimes they are going to ask like this. Stability order. Yeah. So which is more stable? This one and this one, which is more stable? Yeah. So here how many double bonds? First conditions are important. Cyclic, cyclic, double bond, conjugation, double, single, positive, double, single, positive. Yeah. So resonance conditions possible also. Next, here 2 pi electrons. So 2 pi electrons means this is aromatic. This is aromatic compound. This is 4 pi electrons. This is anti-aromatic compound. So everybody knows aromatic, anti-aromatic. Out of which is more stable? Aromatic more stable. Next, what about this one? This is very much important. Don't get confused. So here oxygen having how many electrons? Yeah. So here oxygen having 1 bond. Here 2 bonds. Total 6 electrons. And 2 electrons. You need to count these also. Total 8 electrons here. How many electrons? 8 electrons. So what about this one? What about this carbon? Same logic. This carbon having 2 double bonds, 2 hydrogens. Total 8 electrons. So what about this one? CH2 plus means 2 hydrogens, 1 bond. That indication total 3 bonds. So 3 bonds means total 6 electrons. So here 2 bonds and 2 lone pairs. So total 8 electrons. So everybody knows 8 electrons, 6 electrons. Which combination is a stable combination? 8 electrons combination. Just look at the board. 8 to 8. So that's the reason which is more stable. This is more stable. Yeah. Is it clear? So this is aromatic compound. This is anti-aromatic compound. That's the reason this is more stable. So here 8 electrons combination. That's the reason this is more stable. But when it comes to this one, 6 electrons. 6 electrons means unstable. 6 electrons means deficient. Is it clear? Yeah. Next, very different examples. Just have a look. So first one, second one, third one, fourth one. Completely different examples. Just focus on it. I will explain very clearly. Yeah. So is it aromatic or anti-aromatic or non-aromatic? Same. Is it aromatic or anti-aromatic or non-aromatic? Let's have a look. First one. So double bond is there. next single bond, next double bond, single bond, double bond. Yeah, conjugation possible. Yeah, actually what will happen here? So here this is carbon, this is oxygen, carbon, oxygen, oxygen is more electronegative, that's the reason this bond shifted to this side, and here carbon gets positive charge. So anyhow, this is double bond, this is single bond, this is positive. So resonance possible, and you have to consider one double bond only. Don't consider outside the double bond, you have to consider inside the circle. This is a cyclic compound. Don't consider this pi electrons, you have to consider this one only. Why? Because you have to consider cyclic compound only, don't consider outside. Yeah, so that's the reason here. How many pi electrons? 2 pi electrons only. 2 pi electrons means it satisfies 4n plus 2 into pi electrons, 4n plus 2 into pi electrons formula. If you substitute 0, then it becomes like this. So here 2 pi, you will get a 2 pi. Yeah. Next, what about this one? Same logic. Yeah. Double, single, double, single, double, single. Yeah, resonance possible. So, but don't consider this double bonds. You have to consider this double bond only. Same logic, 2 pi. So this is also aromatic. This is also aromatic. Both are aromatic. Both contains 2 pi electrons only. Here don't consider this double bond, and this double bond. Same scenario. Single, double, 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 single, double, single, double. Yeah. Here also same possible, but don't consider this double bond. Total 3 bonds. 3 bonds means 3 into 2 pi electrons. Then total 6 pi electrons. So is it aromatic or not? Yes, it is also aromatic. Next, what about this one? Double, single, lone pair. Negative charge is nothing but lone pair. Next to single, next to lone pair, single, double bond. Yes, this is also resonance possible. And this lone pairs involved in resonance. That's the reason you have to consider these 2 lone pairs also. Then total 3 double bonds. So 3 double bonds means 6 pi electrons. So 6 pi electrons, you have to count these 4 electrons. 10 total 10 pi electrons. 10 also Hückel's rule. 4n plus 2 satisfy hote. That's the reason this is also aromatic. So ultimately what I want to say is all 4 compounds are aromatic. This is aromatic, this is aromatic, this is aromatic, this is also aromatic. Just have a look. Next, some more different examples. Just have a look. Is it aromatic compound or not? Is it which out of all, which one is aromatic and which one is anti-aromatic, which one is non-aromatic? Yeah, let me check one by one. So what about this one? Double, single, double, single, double, single, double, single. Yes, resonance possible, isn't it? Yes. But on one more important point, you don't consider outside the double bonds. You have to consider only inside the double bonds. So inside how many double bonds? 2 double bonds only. 2 double bonds means 4 pi electrons. 4 pi electrons means it satisfies 4 n pi rule. 4 into 1 into pi, then it becomes 4 pi, 4 pi. Yeah. So what is the answer here? This is anti-aromatic. This is anti-aromatic. Yeah. Next, 6th one. Actually 6th one, 5th one both are similar. Why? Because if you shift this bond here, here gets positive charge like this. If you shift this bond here gets positive charge like this. So this is also anti-aromatic. Resonance also possible like this. Next, what about this one? Yeah, actually this is sp3 carbon, isn't it? Yes, this is sp3 carbon. sp3 carbon means non-planar. sp3 carbon means non-planar. Non-planar means this is non-aromatic. This is phenol. Is phenol is aromatic or not? Yes, aromatic. Why? Because this is benzene ring at any compound aromatic, no doubt at all. 6 pi electrons only. Next, what about this one? Yes, double, single, positive. Yeah, conjugation is possible. That indication this is also aromatic. What is the name of this compound? This compound is benzyl cation. This is very much important. Benzyl cation. This is phenol. Next, what about this one? Yeah, actually this is open chain compound. Open chain compound means non-aromatic. Open chain compound means non-aromatic. Is it clear? Yeah, just have a look. These are also very much important examples. Okay, next, some more examples. Just look at the board. Yeah, what about this one? Double, single, double, single, double, single, double, single, double, single. Yeah, resonance possible, isn't it? Yes. Next, what about this one? double single double single double single double single double single double single double single. Yeah. So these two compounds resonance possible, these two compounds cyclic compounds. So first three conditions satisfied. Yeah. Next here, how many double bonds? 1, 2, 3, 4, 5. 5 double bonds. So 5 double bonds means how many pi electrons? Here how many double bonds? 1, 2, 3, 4, 5, 6, 7. 7 double bonds. 7 double bonds means 14 pi electrons. Yeah. What is our Hückel's formula? 4n plus 2 into pi electrons. 4n plus 2 into pi electrons. Here what is the number? 10 pi. Suppose if you substitute n equal to 2, then it becomes like this. Yeah. 4 into 2, 8. 8 plus 2, 10. So 10 pi equal to 10 pi. Match ho gaya na? Yes. So isliye is it aromatic compound or not? Yes, it is a aromatic compound. Next, what about this one? Same logic. 14 pi electrons. Substitute, you have to substitute n equal to 3. 4 into 3 plus 2 into pi equal to 14 pi. 4 into 3, 12. 12 plus 2 into pi. Yeah, 12 plus 2, 14 pi. Yeah, 14 pi, 14 pi. So that's the reason this is also aromatic. And one more important point, this is a non-benzenoid. This is also non-benzenoid. It doesn't contain benzene ring. These two compounds are aromatic but non-benzenoid. That's the reason these two compounds are called non-benzenoid aromatic compounds. Yeah. So and one more important point, this type of compounds are called annulenes. What is the name? Annulenes. What are annulenes? Polyenes, conjugated polyenes. Aromatic conjugated polyenes are called annulenes. This is a 10 pi annulene, this is 14 pi annulene. Yeah. Next, what about this one? 13th. What about this one? Double, single, double, single, double, single, lone pair. Yeah, resonance possible. So total, and one more important point here, lone pair involved in resonance. That's the reason you need to consider lone pair also. So finally, 1, 2, 3, 4. 4 double bonds, so you have to consider this one, total 10 pi. 10 pi means aromatic, already we have discussed. Next, what about this one? A double, single, double, yeah. But outside double bonds are there, outside don't consider. So this is non-aromatic. Next, here actually this is free radical. What is this? Free radical. Free radical means only one electron. One electron means this is one electron, this is two electrons, total 3 electrons only. 3 electrons doesn't satisfy Hückel's rules. That's the reason this is also non-aromatic. Yeah. Is it clear? These are very different examples. Just have a look. Next, they are going to ask this type of questions also. If you want to solve this type of questions, you need to follow these two key points. What are the key points? Generally, aromatic compounds are diamagnetic. All aromatic compounds are diamagnetic. All anti-aromatic compounds are paramagnetic. Half-filled orbitals means paramagnetic. Completely filled means diamagnetic. Only half-filled orbitals are involved in bond formation. Already we have discussed this type of points in chemical bonding topic also, isn't it? Yes. Yeah, anyhow. Aromatic is nothing but diamagnetic. Anti-aromatic is nothing but paramagnetic. Yeah. Shortcut. AD. Either AAP. AAP. Aam Aadmi Party. Yeah, Aam Aadmi Party. Anti-aromatic, paramagnetic nature. AD, Attarintika Daredi. Pawan Kalyan picture. Yeah. Okay, which one of the following is paramagnetic? First, you need to cross check which one is aromatic and which one is anti-aromatic, like that. Double bond and lone pair. Yeah, this is 4 pi electrons means this is anti-aromatic. Next, what about this one? Yeah, same logic. This is also anti-aromatic. Yeah, this is also anti-aromatic. This one contains 4 electrons. This one contains 4 electrons. This one also contains 4 electrons. 4 electrons means Hückel's rule, 4n pi rule. So that's the reason. What is the correct answer? Which one of the following is paramagnetic? All the above. Yeah. Is it clear? Yeah. So this is aromaticity concept. So please subscribe my channel. If you want to like, you can like. If you want to share, you can share it to your friends. Okay. Bye for now. See you again.